Well, good afternoon. You guys hear me okay? The voice in the back? Um, yeah, thanks, Tim. Thanks, UW for doing this. I first started, I'll talk a little bit about the history, doing this assessment back in, I think the first year I had done a new model was in 96, and then that next year I took it over. So it's been a long time coming, and we had some pretty bumpy roads early on. And I used to open up the center when the campus was open. People could go have coffee and at the cafeteria there, beautiful lake view, and just have kind of an informal week before the plan team meeting get together and to talk about the assessment. And so people in a setting would have more comfort and hopefully get a preview of what's to come and kind of ask questions. Because I'm a firm believer, if anybody tells you their assessments are accurate, they're lying. And if anybody tells you they can look at data and not come up with an explanation, I think that's where a lot of the work needs to be had. So I'm going to show a lot of data. I'm going to talk about what we think the fishermen are seeing and what the fisheries are seeing. And when it doesn't jive with what our assessment or model says, we try to come up with reasons, and hopefully some of that can become clear. And like I said, it's pretty informal. I don't want to make this to be too formal event, although I do have my best sweater on. Robert said he's only seen me talk with this sweater, so I got to keep that going. Well, just a little bit about the background on the stock structure. This is work that Ingrid Spies and Sarah Schell's been doing, and it's in the assessment this year. Don't worry too much about the axes, but they're genetic expressions of differences between regions, and the collection colors are shown, but the symbols are by region for mainly adult pollock. And you can see that the Aleutian samples are close to the Gulf, at least genetically. And then the Bering Sea seems to be quite distinct as a stock. And then way over here, we had important differences from Japan samples. And so that's just kind of the backdrop of why we manage the stock as it's currently designed. And that's in the assessment this year, just the update on those genetics. A lot of our work is, like I said, based on pretty extensive data collection. And I just wanted to shout out to the observer samplers. Especially for the pollock fishery, they've been collecting data at a very high level. And a lot of what I'll show is due to their hard work. And same for our survey group as well. But I just wanted to shout out that, I put a QR code for where the manual can be attained if you have interest in that. And I think I can hide this, right? We don't want non-data ink. Okay. On the advance. There we go. Oops. So what is the size of the catch? I just wanted to highlight the mean's been about 1.3 million tons. No, a little over 1.2, sorry. Gotta get my glasses on. And we've had some, like I said, some bumps in the road. We had some years of poor recruitment, required a quota cut, and that dropped the catch from almost 1.4 million down to 800,000 for a couple of years. And fortunately, we've been able to rebuild and stay at a reasonably high level of catches in the last decade or so. In terms of what the fishing conditions are, these are by sector. Just briefly, a CP is catcher processor. Catcher vessels are boats delivering to shore-based, and motherships are catcher boats that deliver to mothership operations. And these are just the traditional sectors that get allocated parts of the quota, and these are their nominal catch rates, basically how many tons divided by time. And you can see in 2003, most of them by both seasons have shown at least a steady level of catch rate or even an increase for some of the sectors. So 2023 this year. Good fishing wrapped up last month. This is a figure that's actually not in my document, but it's in our Safe Report ecosystem section, which is looking at the discard rates. And so I do have a table in the document that lists the actual discards in the fishery, but I just wanted to point out where pollock sits next to other fisheries. And so this is a discard rate. It's like in that first year, 93, 20% of the longline and pot catch was discarded. And so that's how you read this. And you can see that for pollock, it's a really low level, less than 2% on the average, about 1% in recent years. And but it's a big fishery, so maybe the absolute value is still quite high. And so a lot of that's, if you look at that, it's actually still quite low in absolute tonnages. So you can see the rate drops for longline because that's not as big a fishery tonnage wise, but the absolute value of pollock bycatch discard rates in the fishery, and these are fish, not tonnages, not numbers of fish. Anyway, I thought that's some context that would be useful for those that may not have time to read all the bits of the assessment. Each year we also have, like I said, fortunate information from our observer program, and this is not labeled, but this is the winter fishery distribution over the last 9 years from our observer collections. And just to show roughly where most of the catch is removed during the winter. And this is usually constrained by the ice extent. So you'll see compared to the next figure that it's more in the south and eastern part of the Bering Sea. And just to orient yourself on the slope here, this is the Aleutian Basin. And then you see the shelf area, which is generally 100 meters and shallower. So it's a relatively shallow shelf area, which means it is affected by wind mixing and productivity is quite high. That's one of the reasons why it's such a productive area. And then for the B season, the same type of figure, again, just aggregated up by the ADF and G 6-digit areas that they use. That's what I went by for making these summaries. And you can see that most of the catch in the southern and eastern part is restricted to catcher vessels because it's a catcher vessel operational area. I should have included that, but the catcher processors can fish in there given certain constraints, usually community development quota, and but they usually generally go further north and west in the Bering Sea. So more on observer data, we have these are weight samples. And so this is a depiction, briefly, is the frequency in a tow of what was the average weight in grams of that tow, the average weight of the fish. So basically the observers are sampling numbers of fish and they're weighing those numbers and they get an average weight. And that's a pretty robust number because we have a lot of hauls. And so here the frequency is the number of hauls, not individual fish. And so one thing you can see is it does track. You get patterns in the data between winter and summer. And you can see year classes come through. It also tells you kind of if there's a difference between the A season on the left and the summer season on the right. And this last year, you could see that there were somewhat smaller fish than you might have expected, given the year class estimates that you'll see in a few minutes here. Well, that's for annual look. And now what I want to do is show that annual look, but have it be by week. And just so to give you even more idea of the resolution of the observer data that we have, you can see that as the B season evolves, we have some years like 2019 where it's mostly all big fish. And then like 2021, we had a lot of 2-year-olds in the catch, which was unusual. And likewise, you could see how it evolves in the last couple of years. So the vertical line there is the 500 gram limit. So you can just kind of see that's on average a target size of pollock. It's very good for recovery rates. It's also very good, kind of roughly speaking, on the ages of pollock, being for ages 4 to 6 will be in that group there for that size distribution. Another kind of wealth of information that we get from the observer program is on both the length of the fish and the weight. And so they're individually weighed and measured. And from that, we can get a standardized weight given length. And so this is something I've been doing for quite a while, but it's a way to look at the index of the condition of the fish. And this is something we collect in the observer and the survey as well, and I'll show that in a second. But one thing I wanted to start a little bit of a story on is that this year, 2023, we saw pretty skinny fish in the fishery, and that's something that has caused some concern in terms of the condition, whether it's due to the abundance of a year class that's causing that is yet to be determined. But as I mentioned, the survey data also show that. I'm going to jump to that in this other figure. This is a figure I think Sean Rohan creates for the ecosystem section. And for the bigger size pollock, they get a very low condition factor in the survey. So for both the fishery and the survey, we're seeing some pretty big differences. So that's all just measuring fish and weighing them. The samples also come back into the lab and we age them from the otolith collections that are done on them. And so there are fewer of these, but this is based on the data that are available. So back to just talking about fishery data. What I have here is a figure on the left, which I think I can, well, it's just tracking, sorry for the explanation, but now we're talking about relative to age on the x-axis, and the little orbs, the violin plots, they're configured so that when they're very squat, that means there's a lot of data, and when they're very high in vertical, that means there's not quite as many samples and they're more uncertain. And that could be just there are fewer of them in the collection as well. So you can see that this 2018 year class, there were 3-year-olds in 2021 and 4-year-olds this year. And why there's above the value of 1 here means that, well, as 3-year-olds, they started out heavy relative to the long-term average. And as 4-year-olds this year, they're about average. And that, sorry, 2022. We don't have data from the fishery for this year on the ages yet. So those are being processed now, and they'll be ready for next year's fishery data. But so that's a little bit of a story on the weighted age in the fishery. But just to give you a little bit more view of how we use it in the assessment, as I think I say every year, you know, our assessment models deal with numbers of fish, but all of our management quantities are by weight. And so having a good weighted age applied to our estimates of numbers at age is really important, because the fishing mortality rates are applied to numbers of fish. And that's what we want to be able to map between the tonnage of quota and the numbers of fish that result in the mortality. And what I've highlighted here is just in color code, it seems to be consistent with the previous figure, that it's a little bit heavier than average, but it seems to be getting a little bit lighter as it moves forward. And this is based on a random effects model. So in addition to projecting out to this is 2022, 23, 24, and we need those years to do our projections for the quota recommendations, and those have uncertainties with them that get accounted for in the assessment model. Details that we won't go into, but if you just go back to the previous figure in that, and now we can break this out by season and strata. And so this is the same figure now, looking at it by the A season on the far left. So you can see both the 2018 was lighter than average. Well, that's kind of usual. The A season generally has lighter than average fish because they don't grow during the winter. They do expend energy, and that tends to be their lighter sizes, compared to the B season in the middle panel is showing still lighter than average for that year class, but it's in the far northwest. Another fact or thing we think we know is that pollock in the Northwest, generally at age, tend to be smaller and lighter at age, compared especially to the B season on the right column of data. That's our Southeast area, and that tends to have the biggest fish at age. And so that you could see the 2018 there and how it contrasts across the board. So that's all on average weighted age, but what about catch at age? Well, that's also shown in our data here, and I've just highlighted a few of the year classes, and here the magnitude of the stack of the bar is equal to the magnitude of the numbers of catch that we estimate. And so that's something else that we use in the assessment, obviously. And just to zoom in a little bit, the 2022 is the new data that's used in this year's assessment, showing again that 2018 year class continues to persist in the assessment. So next we're going to move into the survey data, and a couple of the two boats. This is we got the right boats here. Yeah, conducted a broad survey. I'll show you the locations, but they collect lots of information that are used throughout a lot of our assessments. In the Pollock assessment in particular, we use the extent of the cold pool to model the abundance. That's a covariate that's used in the vast assessment that Sophia Wasserman, the co-author, created this year. And that's how the temperature data are explicitly used in this assessment. And just to give you a picture of what the distribution of the actual toe-by-toe catch rates are for the last 4 survey years that we went out, missing 2020, obviously, because of the pandemic. But you can see 2023, anywhere there's a star, that means there was no pollock in that toe. So just to highlight, most toes are having pollock in every set, not so much up in the inner I know them there. But yeah, that's kind of the last 4 years. And the information that we collect along with this, like we do with the fishery, has to do with the size distribution. And this is just the recent time series of length proportions and actually absolute values of length. And what you can see is that throughout time, this survey generally tends to pick up fish that are less than 20 centimeters. And those are generally the 1-year-olds that we see in the year. And so that's kind of used as an index of 1-year-olds in the assessment. And then for 2s, 3s, and 4s, they generally not occurring so much in our survey. And then this year you can see the 40 centimeter and bigger fish are modestly abundant. So a bit of a drop compared to last year, and about the same totals and tonnage wise as what we saw in 2021. Well, that's not used directly in the model, but it is used to arrive at the abundance at age. And this is also something that we've run through Stan Kotwicki's basically his dissertation work to come up with the correction on the density dependence of impact on a toe. Basically, if you get a toe with a lot of pollock in it, it's going to basically be an underestimate slightly of the amount of pollock that the gear encountered. And so that's one of the corrections. And then we also applied age-specific VAST estimates. So these data also are driven by a spatial temporal model that is used to come up with these age comps. So these are the age comps for 2023 that we get. You see some years, obviously ages that are important to the fishery, and then what incoming recruitment might look like as 1-year-olds on the left part here. And just in terms of all the biomass estimates over time, this is just a cartoon of the point estimates from our bottom trawl survey. There'll be another figure where it's actually fitting a model with age composition data, but this just gives you an idea where the 2023 value is relative to the last couple of years. Not great, but not terrible. And then last year we had Oscar Dyson do a full survey of the Bering Sea. Basically, these are the transects that were covered with a northern extension that's outside the standard area. That was just to explore kind of the extension of the Northern Bering Sea and to see if we're getting movement across that way. We also use these data, and shout out to co-authors Tina and Nathan, to reprocess our acoustics data so that even though we didn't get an acoustic survey this year, we still had a lot of data collection from our bottom trawl survey boats. They all have the EK 70 echo sounders or better, or maybe some EK 60s, but they're able to, with a certain protocol, collect the backscatter that we see in the midwater. And that's something that we've been using for several years. This year, they completely revised it and basically extended it to go further, cover a larger area. And we think this is important and an improvement because the areas before were more likely to have hyperstability. In other words, if the population contracts, it's probably going to contract to the area where those index sites were. And now, so we've broadened the area, and if the population is contracting to its more favorable habitat, we're more likely to pick it up with these data. It also, they found a higher consistency with the acoustic directed survey from the Dyson. So that was the other reason to convert to this new index. And this is something I evaluated in September, or presented in September, and gave to the October meeting. So I'm not going to talk too much more about that, but it will be linked in with the assessment this year, the work that we did in September and October for the council. And so this is the same survey, hopefully the right backscatter figure. I had a couple of iterations on this, but these are the acoustic backscatter that are used in constructing the same index. So this is that index there, and these are just all the years of it. So you get a feel for what the densities look like in midwater from the transects of boats moving between their bottom trawl stations. So how do we interpret the survey data? Both indices that were available are down slightly from 2022, but real consistent showing of the 2018 year class. And there seemed to be some evidence of a 2022 year class showing up as 1-year-olds this year. And that from our just a survey look, we expect the spawning biomass projection to have gone down, but still well above kind of the target level. But now on to Andre's favorite dog, the modeling. Favorite dog. So that was kind of the data snapshot. Just would like to cover basically what we did in the October meeting was, as I mentioned, this acoustic vessel of opportunity revision. We basically said this is better data, we're going to use it. We made the comparison there. But then we also wanted to look at some other aspects of the tuning, basically looking at the process error and variance tuning that we had used historically, and made some revisions there, basically getting the process error a little bit tuned in so that it was consistent with what we expect from our survey indices. Anyway, that was a success. Another was collected by the SSC and the plan teams, but then we also looked at other things for coming up with a candidate base that we used in this year's assessment. Sorry. I just wanted to say one more thing there is that another big change, which you'll see in another figure from more than a data aspect, is the treatment of how we compute the spawning biomass. Historically, I had always done it with the biggest data set, which was all of the fishery data, to come up with the mean weighted age. And this year I just said, well, why not do it on the fishery data set, which is still quite large, but closer to the spawning season. So I basically used all the data that were collected during the A season, which we feel is the best reflection, and that changes over time to what the actual spawning biomass would be, given the age structure in that season and the average weights at age. So anyway, on to the model fits from basically this accepted model. The time series of age composition data here is shown in the fishery a little bit differently, but the color code is by cohort, and you can see several cohorts coming through, and the dots are the model fits, and sometimes you'll see things above and below, but on balance through time, they generally fit the data quite well. There's enough flexibility, and we really feel like we have very good estimates on total catch at age. And so we allow that amount of flexibility in the fishery selectivity. Bottom trawl survey also has some flexibility there, basically acknowledging that these fish are not necessarily in our survey zone at all the time, at the same amount in every year. They could be further off bottom or further on bottom, or they can also be off the shelf or into the Russian zone. But more on that later. Robert Levine's going to give us a talk on at the end here on his findings with the moored sounders on the border. Moving to the age comps, you've already seen the one on the left here, but the age comps are just the same thing as the fishery. But here you see the 2023 in the lower right, the new data, and the model's predicting a little bit above what we expected to see there, but that's consistent with the other bits of the model, and also the constraint on the selectivity of that gear. And likewise, we have the fits to the acoustic trawl. These are done every other year. So this most recent point is in 2022, and the age comps that we see from that survey is shown on the right. So it's mostly younger fish that we see in the mid-water. Sorry, and so this is kind of a summary of the fit to the age comps. These are based on Chris Francis's work of, making sure that you're tuning your mean age now in prediction, and observations are shown on the left for each of our main data types, and then just a couple of the selectivity, so you get some idea of the amount of variability that's allowed for both the bottom trawl survey and in the fishery. I'm sorry, this is a fit to the new AVO index with the updated error bars that were tuned in the September document. And then just to spend a little bit of time on the diagnostics for some of the assessment. One of the things that we started to do, I think 2 years ago now, we've had, thanks to Cole Monahan's work on no U-turn sampling and the ability to do that in 80 Model Builder, we've been able to get really good posterior distributions that allow you to, in like 2 hours for this model of over 1,000 parameters. So it's quite efficient. And what we're looking at here are the observations, are the black dots. Those are the data that I get from the survey folks. And then the yellowish scatter plot is what the model prediction would show, given all the model uncertainty. That's what that is. And then the gray dots reflect the model uncertainty and the observation error that the data came by. And so this is a diagnostic. It can be summarized. Paul Spencer has been working on that for all of the data in this particular model to be able to use it for model selection. But those are details I don't want to go too far into, because basically I haven't used them for model selection here, but thought it was useful to at least show some of the steps towards doing that. Another aspect of or was there a question? Another aspect of the MCMC, the posterior distribution, as you've seen, one of the key questions is really how well estimated is that 2018 year class, and what data components are contributing to it the most. And I haven't got a good answer yet. I've shown a figure like this several times, but haven't had anybody say, no, this is the wrong way to think about it. But I'll explain it. Apologies for those that, what's shown on the top is the bottom is just the posterior distribution of the estimate of that 2018 year class. kind of the average 1-year-old is 20 billion. So the average is like over here so it's a big year class. And this is estimated to be a quite big year class. And the question is, each of those panels on the top are compartmentalized components of the posterior distribution, normalized by the mean value. So the idea is, well, if I just basically fit a smoother through the posterior to see, it's like, is fishery age expecting, looks like it's expecting slightly, wants a little bit bigger estimate compared to the values. Let's see, yeah, the ABO, no, that wants to be bigger too, but it's pretty flat. So anyway, it's an attempt at a kind of a Piner plot, but from a posterior distribution. For those that can follow that, I'll leave it there. But the other diagnostic that we look at a lot, and we're going to spend probably a couple of minutes on this one slide. So hopefully you don't get too seasick and you can see it well enough, but you can see right there, like in 2014. So what is this? This is the same model, but subtracting all the data off back to 20 years worth. And so you see 2003 is the first year. It's like just the same exact model, but taking all the data and only running it to 2003 and seeing what the projection looks like. And then doing the same thing, but down to 2024, 2004, 2010. So all of these tend to show the drop. But right around 2014, we had some bad retrospective patterns. Basically, if you peel the data back to 2014, 2015, it said, oh, the stock should have been much higher than what we think it is now. So the underlying line is what we think it is now, right? And so we see a bad retrospective pattern in the middle there. And one of the facts that I think I've said several times here is that all of these assessment models are pretty good at depletion estimates because they know how many fish they caught, what ages they were, and how the stock went down, but they're not very good at predicting increases. You need really, really good survey data to predict increases. At least that's my belief. And these models are just can go astray pretty easily for that effect. Well, what I'm hiding is partly of what's causing this jump up here in that year is the recruitments. And of course, recruitment, the chicken and the egg thing, these are what matter. And what I want you to focus on is like, oh, all of a sudden there's 2 big year classes, and then, oh, they weren't that big at the end. And so we do have the case where you get some strong year classes when there's not all the data are there, and then they end up not being as strong as you might think. And that was kind of the cautionary tale I started last year with this point estimate. Is it going to do the same, come down as more data get added, or is it going to stay as high it is now? Well, we only have kind of a couple of years of insight on that. So I was really proud of being able to do this figure. It even gives you like stop and start controls, all that kind of stuff. But then Cole Monahan had one that was actually way better, and just the figure, it just showed kind of the same idea, but now peeling back data by how many peels you go back. And so I've just plotted a few cohorts in each of the panels, and what you can see is that well, for 2008, it took several years for it to show that it was above average year class. And then it kind of stayed that level and declined a little bit as data were added to the model. Similar to 2012, one of the weird things that I've looked at in the last several years was how 2012 ended up switching kind of with 2013. Both were above average and adjacent, and one became bigger than the other. And that was kind of a unique thing that we haven't seen very often, both back-to-back year classes in this type of trade-off. And then I threw in a weak year class here just to see how fast, it starts at close to the mean, and then it goes to a low value given the data. And then the 2018 here, you can see that this year, last year, the estimate's there, and this year it's down a little bit from last year, but still quite high. anyway, that's kind of the static version of that previous figure. We also look at diagnostics for selectivity, and this was something that is actually pretty important because our management, I already mentioned, it's conditioned on what we assume for weighted age or what we estimate for weighted age, but it's also incredibly important on that predicted selectivity of age. So if the fishery is going to focus on small fish, then the target harvest rate changes versus if it's targeting larger fish, it changes. And so I'm using a sort of an average. And what I'm looking at here are the estimates as they end up in retrospective peels versus what we projected they would be. And the figure on the right kind of shows by year, the dots are the estimates in each retrospective year. That's why you only see one dot here because it's only been one peel. You see lots of dots historically, and they tend to stabilize. And I tried to summarize that to say that, what is the mean age selected? So how do you summarize the panel on the left? And I tried to do it there. And basically it says, well, generally speaking, it tends to be biased young, the projections are. And for that reason, we think it tends to be more conservative. If we're projecting something that we're taking younger fish, then that generally speaking says, well, the harvest rate will be lower because our harvest guidelines are all about preserving spawning biomass, and that's what this is related to. At least that's my thinking about it anyway, of how to try to summarize this type of an effect in the pattern. Just, now onto some final kind of figures of importance. Again, here's the time series of recruitment that we estimated last year. And as you move it to this year, you see almost no change, some minor changes between this year and last year, but the recruitment for 2019 one-year-olds is down a tiny bit from last year. And then I think I do this now almost every year. Is like I talk about when Gary Stauffer came down and said Pollock fishery is going away in 1996. He says there's no more fish, and it's like all these year classes kind of have special sentimental value because you can see like the two I highlighted there. One of them's a 1992 year class, and that one didn't start out very big, and it ended up pretty big, and it kind of like I didn't kill the stock when I first started doing the assessment. I was really happy. Gary was wrong. He said they weren't gonna, fishery was gonna close, and that came through. And then all of these other ones I have little stories on, but yeah, that's the blue line is when I started doing it, and yeah, it's this. I don't know how much storytelling I'll have about I remember the 2018 year class in the coming years. So what else is there about this year class? And this is something I put in the document this year. It's kind of an offshoot of that when I was talking about the 2013 and 2014 year classes here. They were 2014, 2015, one-year-olds. How they swap places. So I wanted to see, are they spatially different? Is that why they're two adjacent strong year classes? And so I made a figure like this last year for those two. But this year, since I wanted to try to summarize more about the 2018 year class or just try to learn more about it, what I'm showing here are the age-specific sample locations from the survey data for two recent strong cohorts. And actually, Robert was saying he came up with a good rationale for why we see the 2018 being so central is just that they've appeared broadly throughout the region. In other words, it's not a very, so the orange dot pattern that you see for the 2008 year class, that's age 2, 3, 4, and then the older fish are generally in the southeast. That's a very common pattern. Troy Buckley has a paper on this years ago and shows this for a number of year classes. And I think we could also characterize certain types of strong year classes as being kind of broadly available versus one that clearly started up in the Northwest and might have more influence that way. Anyway, I'm curious what people think about these. I look forward to some of those discussions. Another thing I pulled out of the ecosystem report, to highly recommend looking through, is these are young of the year length adjusted weight. So it's basically looking at how long a fish is and how fat they are. And just looking at this today and yesterday for 2023, the fact that they're pretty light, skinny for their age zeros might mean maybe not the greatest year class coming forward from 2023. But the jury's out on that. We'll see how this pans out. Anyway, something is worth looking into in the ecosystem report. There's several other things like that are great. Other summary figures. I mentioned that I used a different spawning biomass weighted age, and the difference between last year and this year is primarily due to that. But the general trend is that we'll expect to go down in spawning biomass estimates, but with greater uncertainty, obviously, that we see otherwise. And the other thing I include is looking at the diversity of ages in both the spawning biomass and in the population in general. So, we're always worried genetically and other reasons of if the population spawning biomass is really dependent on a single year class, for example, that might be undesirable just to adapt to all the different changes that might happen in the ocean. So we do try to track it, as far as the spawning biomass diversity, it's kind of below average, but not too much below. And you could track this through strength of year classes as well in terms of the diversity of ages in the population. All right, one more dog picture on projections. And here, I won't go into the details of the tier 3, but I do want to, this is one set of figures that says, well, let's ignore the 2 million ton cap and fish whatever we can. And so the top figure is meant to be catch. It says in the next couple of years, we'll get a normal catch, but Wally's going to get his way and we're going to be able to go above the 2 million ton cap. And that's what would happen. And what I wanted to highlight is that a couple of things. The spawning biomass under that scenario is a lot more variable. These are individual simulations projecting forward. And if you just highlight, looking at just how many are below the target, which means if you're below that target, you got to ratchet things down. It's not a fun place to be, but you also get a lot of variability and lower catch than even 1 million tons, even with the high bump up in 2026. Wally's wish. And then, so compare that with what I think is probably more likely to happen. Our fleet capacity is changing. We're improving the fleet a little bit, but not that quickly. Russia is. But if you actually fish at the recent average, kind of just do the normal thing, and you compare, you'll see that you have fewer periods of catch that's outside the box. It gets lower if you compare that to the above 2 million cap. And then if you do kind of average fishing mortality, you'll still get some incidences of really good conditions. These are all based on simulated recruitments. And you also get relatively few incidences where you're dropping below kind of the static target level. Anyway, I don't know if I explained that well, but I just try to put some highlight out there of, do we really want to have more variable effort and more variable catch quotas given our current system? I think there's some work that needs to be done to help design that. All right, I have a couple, just a few slides left, and then we'll turn it over to Robert to talk about our Russian border effect. But just looking at some spatial environment, I mentioned several times the ecosystem report, and this is a infographic that's in there that talks about how we're trying to take into account in as quantitative a way as we can, but it's a bit seat of the pants, dealing with the risk that of the things that we can't predict very well. Things like predicting that small weighted age, skinny fish, and things like that. And so this is just to highlight the program for in the ecosystem, and this is what the SLC will be using to come up with their recommendation going forward. And one of the key aspects is the cold pool extent. As I already mentioned, it's used in our index value, but I just wanted to couch a general trend. You can see 2023, as already noted, pretty extensive ice extent compared to 2018, 19 here, almost no ice extent. And so before this time, there's kind of been the effect on Pollock biomass. And so the vertical scale here is the mean latitude of the survey biomass over time. And it's just showing kind of a steady increase, a few outliers. 2018, interestingly, is the furthest north, which kind of is odd thinking about that geographic figure of the cohort. That here's the survey value in 2018. It's not the year class, it's just the survey value in that year was the furthest north in terms of the biomass distribution over the whole period. That's plotted by year on the x-axis, but if you look at it by the cold pool extent, so if the cold pool is very extensive, then we tend to see, and this is how it affects our index, we tend to see more fish further south compared to if the cold pool is not very extensive on the left, more fish in the northern part. And so that's something that we think is important and will hopefully link up with what Robert's going to talk about in a few minutes. This is part of something I included in the 2015 assessment, is looking at historical survey biomass estimates in the Navarin region, which is basically just across the convention line, the border, and showing some relationship with warmer conditions, more fish being found in the Russian zone. And then we also see, I don't think I want this figure, but we see an opposite effect with the fishery, but that has more to do with the fact that the fishery operates very close to the shelf and not interior, where that has more of a northward effect. So anyway, that's a little bit different view than what we see in the survey, but anyway, the fishery is there. And if it's okay, we'll switch presenters. And this is my last dog picture. We can have a commentary afterwards. So is that good?
Great.
And so sorry. Robert's a very close pandemic colleague. I always thought he was like maybe 5 feet tall, but he's really tall. I only saw him like from here up. No, Robert's been at the center for almost 2 years now.
A year.
But he's had dealings with the Applied Physics Lab. Maybe you could introduce yourself, but Robert's with the acoustics program.
Thanks, Jim.
Sorry. Robert Levine.
All right. Yeah, so I'm Robert Levine. Thanks, Jim. Yeah, I did my PhD down the street in oceanography and then was at the Applied Physics Lab before starting at the center. And so now I'm at the center in the Midwater Acoustics and Conservation Engineering Group, which is just part of AFSC. So we do the acoustic trawl surveys that Jim's already talked about. We also do a lot of side projects focused on Pollock. And so this is one of the big ones. This was an idea that came together probably like a decade ago or so, and at least has taken a decade to get to this point of being able to collect and process data to be able to do what we're now doing with these moored echo sounders. And I'm going to talk about data that the field period for this was 2019 to 2020. And basically we're now just getting to this final numbers part of this. And so I know there are some folks here who have seen some preliminary version of this, but basically we've presented this to plan team, and we're trying to put a bow on it. And so this is a project that was actually mostly led by Alex Diribertis, and I came in as a postdoc and have been doing the analysis for it, and it's with a bunch of folks at the center, Jim and Chris over at APL. So what did we actually do? Here's a great picture of Alex for scale, but it's a relatively simple premise. The idea was, what is the extent that Pollock moved back and forth between the US and the Russian zones of the Bering Sea? It's just not well constrained, and it's really not well known. And so the goal was just to quantify that movement using one section of the Northwestern Bering Sea. So in 2019, NOAA deployed these 4 echo sounder moorings along the US-Russia border in the Northwest Bering Sea. And they were put at 80 meters, 100 meters, 120, and 140 meters. And this was done based on a retrospective analysis of where the Pollock are, basically, in this area of the shelf. And the main instrument that we really care about here that I'm going to talk about is the 70 kilohertz echo sounder. And this is just comparable to the same system that we use on the surveys. Just going to go right through the data here. So the 4 panels on the right are the complete 1-year time series of backscatter data from each mooring. And these have been compressed into a single echogram. So each one is the full year, and they're ordered from shallow to deep, from top to bottom. I'm just going to point out a few key observations from the time series. The first of which is that, kind of looking at the big picture scale of all of this, the seasonal patterns that we saw were really consistent across all of the mooring sites, and that was really good to see. And most of the variability just comes down to the timing of when those changes occurred, and that's what we'll talk about now. So the highest backscatter across the time series happened in early winter, obviously not when our surveys or the fishery is there. And we see that the highest peaks appeared at the deeper sites, the 120 and the 140 meter sites. And at these areas, the backscatter in January is basically 3 times higher than it is in August, when most of the ships are operating out there, or at least from a survey perspective. All of the sites, though, had the lowest backscatter at the same period of time in April. And this basically corresponds with the coolest periods on the shelf. So I've overlaid the periods of ice cover now on each panel, this sort of sea ice box. And you can see that basically this just falls within that mid sea ice coverage period at each of these sites. So back to that sort of seasonality and the difference between the sites, it really kind of just looks like visually here that the backscatter progressively disappeared from shallow to deep in late winter, and then kind of reappeared this deep to shallow progression again in late spring, following that pattern of cooling that we'd see. So basically, as soon as the sea ice moved in, you start to see that disappearance, and then a little bit before the sea ice is actually fully gone from the region, we see everyone start to come back. So we're trying to get at the questions about movement in particular, at an individual scale even, to understand what's driving these seasonal patterns. And this just starts with tracking individual fish. So as I said, I'm from the acoustics group, so there's just going to be acoustics talk. So this all starts with this one echogram. So this is what one vertical line in those big echograms is actually made up of. This is 3 minutes of observations. And you can see kind of individual lines, and those are our Pollock, we think, swimming around. And we use an automated method to identify fish tracks. And basically that just means taking these observations and linking them together such that we're assuming this is all coming from a single individual. And that's what's highlighted in this red region. That's basically one fish. And when you put that all together, you can see the observations now of this single fish are just in 3D space. So this is real and geographically referenced. And each of the dots here is a single target or a single observation of what's been classified as that single fish. And so we do that for everything we've got. And from these tracks, we derive a whole bunch of measurements about movement of the individuals. The first I'm going to talk about is target strength, which is the color of these dots, which is what we use as a proxy for size. And this is something that, at least for Pollock, is really nicely well established. And basically, before I get into what this plot is, I just want to say there's seasonality in size. And that's something we maybe could have expected, but didn't actually anticipate when we started processing the data. And the seasonality that we see in size is really consistent across all of the mooring sites. So I'm just going to show one example. What you're looking at here is the 120-meter mooring site, and the bottom plot is just showing the histograms of acoustic size over time. So each curve is just the relative distribution of those target strengths, and these are binned in semi-monthly chunks over the course of the year. I added some lines, the dash lines here, which are roughly giving you the reference points for certain aged individuals, what we kind of assume to be the average age, and these are the same values that are used in the stock assessment report. So our zeros through our 4 pluses. And like I said, the takeaway, all I really want you to take away from this is that there is seasonality in size. And you could see maybe some interesting things happen here in May when the fish start to return. We see larger fish coming in first. Kind of in summer, if we look at 2019, and in August, we see this slightly larger fish, and then kind of as more small fish join in, that mode shifts down. And when we started the project, we originally thought that maybe this would be simple and we'd be able to look at the whole data set and just be like, well, we have a reference 35-centimeter Pollock, so we can look at all of our acoustic data with this reference size fish and make all of our extrapolations based off that size. And really, we got to this point and realized that that was not the case. This probably matters for estimating movement. And in fact, we can use these sizes to look at size-dependent swim speeds, which is what we did. And we end up building in kind of different movement as a function of size into the extrapolation of this, into the larger population movement I'm going to talk about in a moment. And so this is kind of gave us a starting point to be able to take those next steps. But before I get there, the second key piece of information that we really get from the fish tracks are where they're moving, the heading and the speed. And I'm going to show a few examples using these rose-like kind of wind plots, which just show the relative headings of tracks during a given period. And again, this is all from the 120-meter mooring, and I'm just going to try to demonstrate kind of the variability and the patterns that we saw over the course of the deployment. And so for what we were interested for this project is really how are fish moving relative to the maritime border, and in some sense, the shelf slope. And so for reference, I'm going to have these lines overlaid so you could keep them in the back of your mind. And this first plot is actually from August, from the summer, when we see some directionality to the east-west, but generally that movement is associated with tidal occurrences in this area of the shelf. And instead, this is sort of a undirected, low directivity time period where no one seems to be heading in any particular direction. If we look at what's happening during that really peak backscatter time in January, now there's a dominant mode of movement. And this is kind of heading to the south, maybe southwest, maybe southeast. And this we infer to be fish that are passing through on their way down the shelf slope towards those warmer, deeper waters that assumed from on-shelf to off-shelf winter migration that we've seen through other intra-seasonal observations. Skipping forward now to the beginning of May, when that backscatter starts to reappear, when the sea ice goes away, and now you see this really strong directivity pattern in our fish tracks. Basically, everyone is coming towards the west, to the west. And this happens at all 4 of the mooring sites, and it extends from kind of this May to mid-June time period. And then finally, getting into July of 2020, sort of back to the pattern that we saw in the summer of 2019. This non-directed, basically what we were referring to as like a milling pattern of the tracks, milling behavior. And so these plots are just showing heading, but I just want to note that we're also getting speeds, obviously, from all of these tracks. And so rather than just lumping this together, we do all that extra step that I kind of already mentioned, where we estimate the speed and direction as a function of size, or target strength at least, before we extrapolate that out to movement. So that brings us to movement. Basically, we take the measurements of that speed and direction from the fish tracks and combine it with the backscatter that we observe at each mooring and use that to estimate our movement. We're looking at flux at each mooring site. At a basic level, this is just the amount of the backscatter times the net speed into the US and into Russia during a given time period. So we're really just looking at that vector in and out across the maritime border. We do this for a single mooring, and then we actually add up all of the mooring movement across the mooring skin, estimate across the line that these moorings represent. And that's what's shown on the bottom right. Take those point measurements and extrapolate them out to create this representative transect along the border. And as is kind of shown here, but this line represents depths from about 70 to 150 meters. So that's our full transect that we're going to measure total movement across. What we see, based on the observed backscatter and the tracking, are seasonal patterns in the movement, as we would expect. And this figure is showing the total movement of backscatter estimated across that mooring line, where the positive values here represent the movement into Russia, and the negative values represent the movement into the US. So it depends if you want to be US or Russian centric, but basically in my head, I'm kind of thinking north-south. So that's this towards Russia, towards the US. Really, it's northwest, southeast. The orange line is the net movement during each of those semi-monthly periods. And the gray region, or this shaded orangish region, I guess, is the 95% bootstrap confidence interval for those dots. And so first, to highlight the seasonality that we see, there's sort of this pattern that goes through, and I'm sorry that the color isn't so distinct right now, but in summer, when abundance is high, the net directionality is really low, and so overall our movement is small. Our movement is low just because our tracks don't show anyone going anywhere. In late fall and winter, there's this really strong directionality south, or relatively strong directionality south, and really high backscatter. And so that's driving this movement into the US. In winter, or that's kind of fall winter, in this winter, early spring period before anyone starts to come back, there's just really low abundance. Backscatter is minimal. So we have almost no movement, and that's just being driven by the fact that there's basically no backscatter present. And then in spring, when that westward directionality combines with that increasing abundance or increasing backscatter, we end up with this increasing movement into Russia. And in summer 2020, that starts to kind of settle back out as those tracks switch back to this kind of milling behavior that we saw in the previous summer. So the kind of conclusions for this is that twice as much backscatter moved into the US than into Russia during the 2019 to 2020 deployment period. The total backscatter that moved into the US in winter was 1.7 times the total backscatter that we actually see during the entire acoustic trawl survey of the Eastern Bering Sea. And one of the caveats to this is that there's evidence that a large portion of this backscatter is coming from the small fish. So there's actually a variety of factors that limit our kind of confidence in this and why we don't take the next step into biomass, et cetera. But the way we put this into context is to consider the magnitude of the backscatter to those acoustic trawl surveys. So like I said, what we can say, the backscatter that moves between sectors is large relative to what we see during the entire survey, but the evidence is actually there from the mooring data. In particular, the water column backscatter is much, much higher in winter than it is in summer. Backscatter across the array, total across the array, is 2.3 times higher in January than it is in August. And again, that's when our acoustic trawl surveys are happening, kind of that June to August period. And so it's possible some of this is attributable to behavior. There are fish that may be coming off bottom in winter. These are semi-demersal species. Or what we do know is that these pollock tend to kind of aggregate near the ice edge or stay in preferable conditions. And so you can think of it as fish kind of piling up as the ice is coming south off of the shelf, pushing more and more fish into this narrow but preferred area on the shelf slope. There's also evidence from the target strength data, as I said, that the backscatter really might be coming from a lot of that small fish. And this goes back to that 2018 cohort, where those small fish have really high backscatter, but relatively low biomass for that backscatter. So basically, if we tried to convert that to biomass, we'd be over extrapolating the backscatter of a 1-year-old to a comparable 35+ centimeter fish. When we start to look at why we see these patterns, what we found is that it just looks like polyps may be following the temperature gradient. The net difference in movement that we saw during the course of the 1-year deployment really looks like it's driven by the shift in the population due to annual temperature differences, or its covariates, ice, light, or salinity as the sea ice is melting and intruding. And so in the box plot on the right, what I'm showing is the first box are all of the observations where water column temperatures in Russia were higher than they were in the US during that period. So basically, we look at what the temperature gradient was during our semi-monthly period. And that box is sitting just below zero. Do I have that right here? And so indicating movement into Russia. So basically, this is when you have a period of time. Net movement of backscatter. Sorry, net below zero. This is when water temperatures are decreasing across that time period. We have net movement into the US. And when water temperatures are increasing during this time period, we have net movement into Russia, basically when temperatures are warming over that semi-monthly chunk. Sorry, conflicting notes. So taken as sort of an oversimplified example of all of this, summer 2019, and Jim showed this in those cold pool slides, that 2017 to 2019 period was really warm. And summer of 2019 was kind of the end of this historically warm multi-year period, with evidence from the US and Russian fisheries that a large portion of the stock was just moved into the Navran region, or was present in the Navran region, I should say. And so the shaded region here, that the sort of lined area of this red blob, is just showing the northwest leading edge of that population as it crosses the region of the moorings. This is, again, a cartoon example. And then the following winter, the population seasonally retreats into warmer, deeper water, where the northwest edge is now to the southeast of our mooring transect. So the whole population comes back into the Eastern Bering Sea and more concentrates along the shelf slope in the southeast area. But the following summer in 2020, we didn't have the same level of heating that had occurred in 2019. And so the Northwestern Bering Sea was cooler than the previous year. We saw that cold pool kind of was starting to come back, and a greater portion of the population just stayed in US waters. So this is sort of our simplified version of what is happening over the course of the deployment period. So just to wrap this up, the kind of takeaways from this is that there is a substantial exchange between US and Russian sectors. And this is something that was probably always assumed, but never quantified. And so this was a lot of work to get to this point with these moorings and figure this out. And it's nice to kind of say with data, there's a substantial exchange between US and Russian sectors. The movement is really concentrated in those two periods, that winter southeastward migration, and then that late spring, summer northwest migration into Russia. The seasonal patterns were really consistent across all 4 moorings, and something we didn't know occurred was this really peak abundance in winter. That's very different than sort of the assumptions that go into surveying the fish. And the fish migration appears to follow the temperature gradient. And so kind of the conclusion from that is that temperature really affects the proportion of the stock that's found in each sector. So year to year, that variability in temperature across the shelf affects how much the population might expand, contract, et cetera. And then just because this was written for Plan Team and because Jim's here, the sort of tagline on this is, we still don't quite know how maybe this fits into the assessment and what the next steps might be for using this data. How do we establish sort of a mechanistic relationship that can be used for the stock assessment itself, or moving forward for the Plan Team and the council? So that's that. And now I think Jim left my question slide here. He did.
Perfect. I think we have time for questions. I don't know if there's any.
Yeah, we have time for a few questions here, and then we have social after. So how about Jim, if you want to call on people, and then a question for Jim or Robert.
Go ahead.
during the pandemic? Like, why couldn't you collect data now during the pandemic? Is it because nobody was out there because of the pandemic, or at its peak?
That's a great question. The question is why didn't we collect data in our surveys during the pandemic is because we had very strict protocols, and we actually did do some surveys in that winter that were successful, but by the time summer happened, things were already locked down, and we just couldn't staff the ships. But I will say that we did have observers in fishing boats, so we were still collecting data from fishing boats who managed to navigate the tough pandemic constrictions. And maybe Wally, you could add to that.
No. Very interesting data, very interesting analysis. I think it raises probably more questions than different answers. That's the beauty of good science. Question I have is, you don't happen to have genetic profiles of the fish there. So the question that raises in my mind, how do we know that those aren't Gulf of Anavir or say Western Bering Sea stock coming south that you're seeing rather than an Eastern Bering Sea?
Yeah, so the question for the Zoom people, basically, how do we know? We don't have genetic data, so how do we know that those are US fish and not Anadir fish? And I will say, we don't. However, we do know the bulk of the spawning time period for pollock in the Eastern Bering Sea is kind of that winter phase, right? And we saw directed movement into the US basically just prior to that winter spawning period, right? So it looked like, at least from the data, without making any other assumptions, it looks like fish were coming into the US or coming southeast across the mooring transect during and just prior to the assumed period of Eastern Bering Sea spawning. Is that that's the clue that we have, and that's kind of the level of conclusion that we've made from that, is that these are likely fish that are spawning in the US just because we see that movement into the US during the time period we expect them to be spawning.
And I'd probably add to that we don't really know how much spawning occurs in the north part because of the ice extent, and it's always been an open question to me how much spawning actually occurs that far north. Andre?
Yeah, as usual, great talk. You didn't have some slides you usually have, Jim, and I remember them all. This last talk has really got me thinking. I mean, in the sense of what you care about, in some sense, is what is the net effect of movement at the time the survey occurs, because that's where assessment bias will come in. And it wasn't clear to me that we really know what the net, we can speculate even what the net effect at that time is. But it seems that that's going to be the key consideration from the point of view of how does it affect the assessment rather than the population. I don't think there's an answer to that, but that seems to be the key challenge. My question really was, you touched on it really briefly, was selectivity and your apparent misspecification of it. And I was wondering how that gets carried forward into the management advice, if at all at this point, because it looks like your 1 year ahead forecasts aren't terribly hot. And, to what extent is that captured in the assessment? And if you can answer my previous question about how do you get corrections in survey data, answer that one, because it's more exciting, but you don't know how to do it.
But I'll answer
the entire question.
the last question first. Jim, why are you so dumb? No,
I'm going to say that.
no, the question was how to deal with the uncertainty in the future selectivity, and that's something that we, in theory, do have our tier 1 adjustment. We didn't really go into how uncertainty plays a role, but having uncertainty in things like weighted age and future selectivity actually adds to the uncertainty, and that results in a correction downwards in tier one. So it's not a very big correction, so it's not going to be super satisfying, but it is inherent in this assessment model that that level of uncertainty does get propagated. And I'll just gander that I don't get more criticism, and I should, putting variable selectivity of the bottom trial survey. I mean, from the very first time I did that, I said, well, the survey doesn't cover all the fish the same way every year, and we don't know how much it varies. And so that's one of the reasons why we generally fit the survey pretty well, but also that, you know, it's not great because the fish aren't behaving in a perfect way for our survey gear. Frida, you had a question?
I just wonder if there's a relationship between the availability of food for the fish and their temperature preference, whether they would like warm weather, whether they would go into warm water if food is available, and if food is not available, they would prefer cold temperatures.
So questions about food availability, and I don't know if Robert has anything, but I can try to add to that, being temperature related in that ecosystem status report. It's a fairly large document. There's a couple of sections that talk about prey availability, and for the early life history, they make a lot of conjecture, I should say, about survival in the type of copepods and euphausiids that are available for overwintering. So the fat content is something that is important for the early life stages. As far as food availability for subsequent ages, it seemed like 2018 was a warm year and it produced the big year class. And, you know, obviously something must have been right. And I kind of do think from the data, it seems like the fish started out pretty healthy and big, and that's why they showed up pretty healthy and big, but maybe now they're suffering the consequences of the food availability at bigger sizes of fish, not the early life.
Just being aware of time and recognize some people might have other things to do. So I'll wrap up the formal bit. First, I just hope everyone will join me in thanking not only Jim and Robert, but everyone whose work went into all of this work. Thank you, everyone.